Have you ever wondered why cities are hotter than rural areas? In this video, I'll show you how to perform a full urban heat island analysis using Landsat 8 data inside Google Earth Engine, including land surface temperature calculation, NDVI comparison, built-up area extraction, and urban heat island intensity mapping. So what is urban heat island? So for example, in the cities, we have concrete. So buildings are built using concrete, and so concrete absorbs heat. Since there is less vegetation, the rooftops tend to trap thermal radiation, and for this case they reduce the evapotranspiration. So urban heat island intensity, we shall do urban temperature and also rural temperature, then we shall find the difference between the two, and that way we shall come up with urban heat island intensity. So in this video, that is what we are going to cover. Let's get started. Okay, so in your search bar here in the Google Earth Engine code editor, just type in Landsat 8 collection 2. We are going to use the Landsat 8 collection 2 because it is atmospherically corrected, and we shall also use the band 10, which is the band that will help us calculate the LST, and then we shall use the LST, which is land surface temperature, to measure the urban heat island. So I'm going to click here on the Landsat 8 level 2 collection 2 tier 1, and here we can read through some description. I'm just going to change to the light theme so that we can see that, then I'll go back. So here on my extension, I'll change that to light theme, and so you can see it says that this dataset contains atmospherically corrected surface reflectance and land surface temperature derived from the data produced by the Landsat OLI TIRS sensors. So you can see they say that these images contain 5 visible and near infrared bands and 2 shortwave infrared bands processed to auto-rectify surface reflectance. Then they say that the Landsat 8 surface reflectance products are created with the land surface reflectance code. And yeah, so this is the description about the dataset. You can check out some of the descriptions, but so let's look at the bands. So you can see here that we have the band, which is the surface reflectance band 1, and this is the band, the coastal aerosol surface reflectance. That is the description. We have band 2, band 3, 4, 5, band 6, band 7. We have the aerosol. Then we have band 10, which is the band 10 surface temperatures. This is what we are going to use, and you can see some of the description here, and also the units are in Kelvin because this is temperature. So to get started, you need to so go to extensions, and then I'm going to disable the light theme, enable my dark theme here. Okay, so here you need to have your you need to import the data set. So if we go back and type in Landsat 8 collection 2 tier 1, this one here, we are going to import this. So you can copy the collection snippet like this one, or just import and it will go to your data set. So I'm going to import this and it will go there, and then you can change this to, let's say, collection. You can say collection. If you don't want to import, you can still just copy the collection snippet here. Okay, so I would like to just copy the collection snippet, but you can still keep it keep this one here if you like. So if I copy the collection snippet, I'll have to create a variable and say variable collection is equal to, then I paste that here as image collection. And so we have the image collection. We need to filter out the bounds, the bounds. To filter out the bounds, you need to have your shapefile. So I'm going to use the shapefile for this county here. So I go to my assets, and then import this one here. So after that, I can just rename this to its original name, and then now I can go ahead and filter these bounds. Another thing I'd like to mention is that you can create a buffer between these point, so that you just work with the buffer instead of, let's say, maybe wanting to have a shapefile. So to do that, you can just say var, then I like to pass in the variable name. You can just say buffer, if you like, is equal to, then use the ee.geometry.point. So we say ee.geometry point like that, and then you pass in the point, so the latitude and the longitude. So here I'll take the longitude as 36 point something like 82919, and then negative 1.2921. Then at the end I say dot buffer, so I call the buffer function like this, and I pass in the distance. So in meters, let's say maybe you like to have 2 kilometers, so you can say 2 kilometers, or 25 kilometers, you can say something like 25,000, and this will be your 25 kilometer radius. So if you do that, you will now use the buffer to filter out the bounds here. So I'll just keep this one here and continue using my shapefile. So here you go, after this you say dot filter bounds, and the bounds, of course, we are going to use our shapefile, and then you say filter date. So it's supposed to be dot filter date, because it is a continuation of this function, filter date, and we are going to try out 2023 January date 1st up to December 2023 December 31st. Okay, so after we've done that, then we can also filter out the cloud cover. So say dot filter, and I say ee.filter. ee.filter is supposed to be capital, so filter dot less than, so we are going to filter out clouds less than something like, so we take the cloud cover. This variable is supposed to be the same as what we have in the image description. Then I would like to get the cloud cover of less than 10. So after doing that, then I'm just going to put a semicolon and save this file. So I'm going to save this file as urban I'm going to save this as urban underscore heat underscore island, like that. So I'm going to save island like that. So click on OK, and this is going to save your project. Yeah, so the project is saved. So the next thing is that we need to get the cloud mask function to remove some of the clouds that will have overlaid over our image collection, because we do not want to get maybe some errors. So you need to remove the cloud on your image collection, so that you just work with the clean pixels. Okay, so we have loaded our data set. We can also, this one's supposed to be collection. We can also now we are going to calculate or remove the cloud. So to do that, you need to create a function and say function mask Landsat 8, mask Landsat 8. Then you say this is a function. Oops. So this is a function, and in here we need to get the QA mask, which is the image, which is the band that will help us to remove the clouds, is equal to the image, and I need to pass the image as an argument here. So the image, and this image is, we are going to select the pixel, which is the QA here. So QA underscore pixel, like that. Then we also need to create the mask. So I'll say variable mask is equal to the QA that we just defined dot bitwise and from 1 3, then I'll just say dot equal 0, like so, and then I like to return the image. So here you just say return your image dot, then you update the mask on the image. So update mask, then you pass in the mask. Okay, so this way we shall have removed the clouds that are on our image. So here I'm just going to say variable image is equal to the collection that we declared here. So the whole image collection, and we map through corrected image. So here you can see that we are just working with that image. Remember, an image collection is a collection. Obviously, it's a collection of images. That's why it is an image collection. So we just pick a single image and we remove the cloud. So we are going to use this image that we removed the clouds and then map through each and every other remaining image in that image collection, so that the corrected pixels apply to all the images in the image collection. So I'll say dot map, and then we pass in the function. So I pass in the function like that. Then I say dot median. So dot median. Then I say dot clip. So we clip to the region of interest, which is our shapefile, like that. Okay, so I'm going to save that. So the next thing is now that we need to calculate the land surface temperature. So since we have a corrected image, which is an image there, we need now to calculate the land surface temperature, which is like a tool that will help us to measure urban heat island. So here you say variable LST is equal to the image, which is now this image here. You can give it another name so that you do not confuse. So image, and then we say dot select. Now we select the band 10, which is ST underscore band 10, like that. Then we can now change, because since it has the Kelvin, we can change to degrees Celsius. So say dot multiply, supposed to be lowercase, multiply by 0.003411802. Then we say dot add. We're going to add 149.0, and then we subtract from 273. So subtract from 273.1.15, like that. Then we are going to rename this as land surface temperature. Then down here you can say dot rename as LST. So we are going to rename that band to now LST instead of just band 10. Okay, so after that we need now to calculate some NDVI. We shall use NDVI to compare the urban heat island and also the built up areas, and yeah. So here NDVI is the normalized difference vegetation index, and the built up will be, of course, normalized difference built up index. So down here you need to calculate the NDVI. You can have a comment and say NDVI You can also have a comment here and say get LST in degrees Celsius. So down here you need to create a variable and say variable NDVI is equal to the image dot now normalized difference, and then you say you are going to take band 5. So we take band 5, say SR underscore band 5 and SR band 4. So we need the near infrared and red band, supposed to be in quotes, so change to quotes here, and we also need to get SR underscore band 4. Then we shall say dot rename this to NDVI. Then we can now also calculate NDBI, and this, do not confuse with the band or bear. This is going to be built up. So you say var NDBI is equal to, we need to get this, but we use a different bands and paste it here like so. And so we say image dot normalized difference, and we need to use band 6. We need to use band 6 like that, and we need to also use band 5. So the shortwave infrared and the near infrared. Okay, so after doing that, since we have now NDVI and NDBI, we can now classify our urban and rural. So down here you need to classify. So we say var urban, so we need to get the urban is equal to the NDBI dot, then give it like a threshold. So if it is greater than 0.1, then that will be our urban, and variable rural is equal to NDVI dot greater than 0.4. So 0.4. This is just a threshold. You can use a different threshold. Then we have now classified like our image into rural and urban. So we need to extract urban and rural temperatures. So up here you can say variable urban temperature is equal to, so the urban temperature is equal to the LST. So remember the LST is this LST here in degrees Celsius, and we say LST dot update mask, then we mask over NDBI that we have, not NDBI. Of course it is NDBI, but it is urban. So we use the variable because that NDBI has a threshold. So we want to capture this threshold, which is stored in this variable here. Okay, and then we say variable rural temperature is equal to LST dot update mask, and we pass in rural like that. Okay, so we have now the urban temperature and the rural temperature. We need to calculate the mean temperatures. After getting the mean temperatures, we shall use those mean temperatures to now get the urban heat island. Okay, so to get the temperatures, the mean temperatures for both urban and rural, we need now to calculate those. And to do that, you need to declare a variable here and say urban mean. So this is going to be urban mean. Urban mean is equal to the urban temperature that we have here. So copy that one, urban temperature, and say dot reduce region, and inside here we need to pass some parameters. So reducer reducer is going to be EE, which is the earth engine dot reducer and dot mean. So we get the mean temperature. Do that, and then the next parameter is supposed to be geometry. So say geometry, and this is going to be the shapefile that we are using. Then the next one is the scale, and scale is going to be 30-meter resolution. And then lastly, we need to get the maximum number of pixels, and this is going to be 1 times 10 raised to power 9. So we say this as 1 exponential 9, 1 exponential 9, like that. And this way we now have our urban mean temperature. So to get the rural temperature, we just copy this one here and reuse it down here. So you just paste it down here and change this to rural mean temperature is equal to the rural temperature. So this is the variable up here. So urban temperature, rural temperature, and then we calculate the mean. So the parameters are the same. What changes is just the image. So rural mean is equal to rural temperature dot reduce region, and then you pass in the same parameters. So after that, you can now print out these and see the results. So you can say print, and we're going to print urban mean temperature, and this is going to be urban mean temperature, like so. And then we pass in the parameter as urban mean. So copy this one, Control C, and then Control V, urban mean. Then duplicate this and say rural mean. So this is going to be rural mean, and copy the rural mean and paste it here, Control V, like that. So urban mean, rural mean. Make sure you also change this from NDVI to NDBI. Remember, we copied this, so that is it. So here I'm just going to say ignore this because just want to see everything. So put some colons like that, Control save and run. So after that, you see that the urban mean temperature is 45 degrees Celsius and the rural mean temperature is 33 degrees Celsius. Okay, so next thing is that we need to have calculate the urban heat island, which is the difference between the urban temperature and the surrounding rural temperatures. That is what is actually the core of this video. So to do that, you need to calculate the urban heat island. We say variable urban heat island is equal to this is equal to the urban temperature. So urban temperature, like that. Then we say dot subtract, since we want to get the difference, subtract, we are going to subtract the rural temperature. Then we say dot rename, and we are going to rename this to now urban heat island, like that. Okay, so after doing that, we need now to have some visualization parameters because we want to add this urban heat island to the map. So let me just confirm urban temperature. We have urban temperature, subtract rural temperature, we have rural temperature, then we rename to urban heat island. So let's get the visualization parameters. You say variable lst vis is equal to an object with the minimum value as 20, the max value, let's get the maximum value as 40, and let's get the palette. So the palette is the color, and this is a list of colors. So we need to get we need to have blue color. We need to have blue color, like that. Then we need to get cyan color. Then we can also have the green color, green, and let's have yellow. Then lastly, let's have red. After that, now we can add things to the map, but remember we have not centered our object. So to make sure that we are zoomed into the region of study, we need to say map.center object, map.center object, and of course we are using our shapefile. Then we can zoom into 10 zoom level. Then now we can not say map.add layer, map.add layer. We are going to add the LST. So we have LST, map.add layer. We add LST, and then we also pass in the visualization parameter. So just copy this variable here, Control C, then Control V, like that. Then of course we need now to rename this as land surface temperature, like that. Then the next thing is we need to add the NDVI. So map.add layer, we are going to add NDVI. Of course we need to add NDVI, and we also need to pass in some visualization parameter. So here we can say min. That's the same as what we have done here. So it's like we are taking all this and putting it inside this. You can separate them, but I would like just to put it here. So min is going to be from negative 0.5, and the maximum value is going to be 1. Then can also say the palette. I'm going to ensure the palette, so I say palette. The palette is going to be a list of colors, of course, a list of colors, and we can have brown color there. We can have yellow color, we can have yellow, and then lastly we can have green, like that. I'm going to duplicate this one more time, and instead of NDVI, I change this to NDBI. The minimum value is from negative 0.5 to 0.5, and then I'm also going to change the color. This is brown, and so for instead of brown we are going to use white. Instead of yellow we shall put gray, and then lastly we can use black. So that is it. So let's go ahead and save the code. So click on save and then run. map.add layer. So since we have duplicated this, it means we have the error all around. Okay, so at the end I would like to put a semicolon, Control save again and run the code. So we still get some things printed on the map. So here it is. This is layer 3, layer 2, land surface temperature. Oops, we didn't give the correct names here. So we are supposed to rename these actually. So outside this we need to rename to, because this is NDVI, so we need to rename to NDVI. Let me use capitals, NDVI, and this is the NDBI. So save that again and run the code. Yes, so we get the NDBI, NDVI, and land surface temperature. So you can check and uncheck to see the land surface temperature there. I think the visualization for the map is not something that should worry you so much about the colors, but what should be the most important thing is to get the pixels to the place. So for example, if I just go to NDVI, which is the vegetation index, and then so if I just go here to the NDVI and click to somewhere, maybe somewhere here where there is yellow. Here you can see that I get the NDVI as 0.26, and if I click somewhere else, let's say at the CBD here I get 0.03. so that means that the you can see the pixels here, 0.03 is lower than 0.26, which means this area that we had 0.26 has the highest vegetation cover than the what we have as 0.03. So that is the important thing that you just need to note. Colors could be anything. It doesn't necessarily have to be like green or red or yellow. These we have just put here for visualization purposes. So we've got the difference, the urban mean temperature and the rural mean temperature. So we also need to export our image to Drive. Maybe you like to do some advanced visualization in another GIS software like QGIS or ArcGIS. So to export to Drive, you need to just say export. So you just need to say export dot image dot to Drive. So export image to Drive, and here you need to pass in some parameters. So we need to get the image, which is our LST. We need to get the description, which is like the name of your file. So description, you can say something like LST underscore export, LST export, and the scale, of course, 30 meter resolution. So you say 30 meters, and then the region, which is the shapefile that we are using as our region of interest, and this is suppose don't put in quotes like that. So we have the region as the shapefile that we got, and then lastly we need to get the file format. So the file format, and this is going to be a geotiff. So you can say geotiff. Geotiff. This is complaining. Oh, we are supposed to put colon here. So say Control S or save your file and then run the code. So this is going to export this, but you need to click on run. So click on run, and this is going to run and export your image to your Drive. So the Drive that you connected with Google Earth Engine, especially the email or the account that you are using to do your analysis. So if you go to Drive after you're clicking on run and export, you will find the image is actually there. Okay, so let's talk about the difference of the urban heat island intensity. Since in the urban mean temperature we have 45 degrees Celsius and the rural mean temperature is 33 degrees Celsius, this one tells us that if we get the difference, since that is the urban heat island intensity, is just the difference between urban mean temperature and the rural temperature, the areas that are surrounding the urban. So if you get the difference, you will see that if you take 45 and subtract 33, this is 2 here and this is 1. So you get 12 degrees Celsius. So if you go 12 degrees Celsius, that means that the urban temperature is 12 degrees Celsius hotter than the rural surrounding temperatures. So important thing, the core of this video, to get the urban heat island. So the difference is 12 degrees Celsius. That means that the surrounding areas are the urban to the urban region are 12 degrees cooler, since we have begun with the rural. But if we want to use hotter, then we say urban is 12 degrees hotter than the rural. So that is it. If you've learned something, make sure to leave a like to the video or leave a comment. If I missed out anything to explain, I will love to respond to your comments. Also to mention, I have a course on land use, land cover, and change detection. You can check it out. I'll leave the link in the description. So thank you for watching, and I see you in the next one.